Hello, everyone. My name is Yuna Noh, and I am a senior researcher at the Maritime Transportation Big Data Office at KOMSA. I will guide you through today's lecture on big data-based maritime safety management and tell you about the concept of big data with examples of its usage in maritime traffic safety in Korea. Big data refers to a technology that extracts value from large data sets and goes beyond the collection, storage, management, and analysis of existing data. The 5 V's are often used for talking about the characteristics of big data, and they are volume, variety, velocity, veracity, and value. Depending on the researcher, 3V, 5V, 7V, and 9V may be used to talk about the characteristics of big data, but I'm going to refer to the 5 V's as it is the most common. Volume refers to the size of data. As data storage technology advances, the amount of data we deal with is also very large. When dealing with large data, the distortion of information can be reduced compared to sample data. Variety refers to the variety of data types. One of the characteristics of big data is that it includes not only structured data, but also various data such as images, videos, voices, and texts. Velocity means that the interval between the occurrence of the event and the collection time of data is very fast. Veracity is a characteristic of big data that means reliability. As the amount of data increases, the amount of false data also increases, so it is necessary to consider whether it is worth analyzing. Value means extracting meaningful patterns and results from big data with these various properties. This big data technology is not only referring to simple data, but is widely used as a concept that encompasses data acquisition, storage and management, analysis, and utilization of valuable results. Big data was first introduced in 2012 by Gartner's Hype Cycle in the US. Big data existed before that, but since 2012, it has been positioned as a specific technology. During 5 periods, from the trigger period of the technology to the peak, recession, reemergence, and stabilization periods, big data reached the peak of expectations as soon as it appeared. However, it then disappeared from hype cycle after 2015. According to numerous analysts, the reason behind big data's disappearance is that it is no longer a single technology, but a paradigm that has transformed into a foundation for multiple technologies. This is because most of the emerging technologies, such as data science, cloud computing, AI, deep learning, and IoT, are technologies that are based on or are utilizing big data. Now then, let's see how big data transformed into this paradigm and is being used in Korea's maritime sector. The Korea Maritime Traffic Safety Authority was established as an institution in charge of maritime traffic safety with the purpose of reducing the ever-increasing marine accidents, establishing the maritime traffic safety system, and implementing policies to foster a culture of maritime safety. Looking at the roles of KOMSA to establish the maritime traffic safety system, it has implemented a system that collects various data from inside and outside of the authority, analyzes the causes of maritime accidents, proposes policies, and supports traffic safety management. The purpose of establishing such a system is to achieve the mission to protect people's lives and property through a virtuous cycle structure based on a big data platform. In order to construct the big data-based maritime traffic safety system, the corporation collects and analyzes data, including ship inspections, operation management, marine environment, marine accidents, and insurance, and provides maritime safety services to the central government, fishermen, shipping companies, and the general public. We are in the business of providing services. Next, I will tell you how we analyze and utilize this various data and provide it as a service through some examples. Above all, it is of the utmost importance for the government and public institutions to protect people's lives and property from marine accidents. In line with the characteristics of a region where a large proportion of small fishing vessels operate in coastal waters, such as Korea, and at the same time, this type of vessel accounts for the majority of all marine accidents. We have planned a system for predicting the risk of accidents in coastal waters and providing vital information. Along with the increase in marine traffic, Marine accidents are increasing every year. In addition, great efforts are required to prevent the main cause of accidents, which is human error. In order to reduce human error, we have developed this system to find a way to predict and warn of risk factors that may cause accidents in advance. These days, in land transportation, when reversing and approaching an object, an audible warning is given. Also, many rear cameras have been installed in vehicles. Recently, various safety support systems, such as adaptive cruise control, ADAS, and driver state warning systems, provide a warning sound or control the vehicle when accident risk factors occur. By benchmarking this technology, we have designed a service that informs of accident risk in advance, even at sea. To do this, data collection is the first step. It is to identify and collect what data is needed to develop the desired service and which institution has the data. The most basic data for maritime traffic safety are ships, people, and the environment. Based on past maritime accident data, ship information such as ship type, tonnage, and age, personal information such as age, gender, and career, and environmental information such as wind speed, wave height, and sea fog are combined and utilized. Through data collected by this method, major marine accident risk factors are explored, and causal relationship is derived by accident type such as collision, overturning, floating, drifting, stranding, etc. The significant variables extracted are combined with additional environmental variables to predict the risk of accidents by sea area through deep learning, and the predicted risk supports decision-making by conveying the visualization of each sea area grid in Korea. The overall project system for accident risk prediction and information service is as follows. First, to build big data by collecting various data such as marine weather, accidents, and ship positions. Second, using this data, we create a marine accident prediction model through the Advanced Analysis Model. Third, developing the analysis system and information provision system using the predictive model. Fourth, we provide services through a mobile app or the web that can easily be used by the public to warn of accident risks and provide information to the central government and related organizations to support safety policies, systems, and preventive actions. The second use study is on emergency ship operation support services that support securing the golden hour for reducing casualties in the event of marine accidents, a project currently in progress by the corporation. Unlike other transportation fields, maritime accidents are continuously increasing. While road traffic accidents have decreased over the past 5 years, marine accidents have been steadily increasing over the past 5 years. In addition, it can be seen in the slide here that the fatality rate from marine accidents is very high at 11.6%, while it is only 1.8% for road traffic. Every 10 accidents, at least one results in death. Why do marine accidents have such a high fatality rate? If you experience a traffic accident on land, you may get out of the vehicle and wait in a safe area off the road, but not at sea. The average water temperature in Korea is 17.3 degrees, and in the Namhae area, where there is a lot of actual fishing, the water temperature drops down below 16 degrees for at least 7 months during the year. When the water temperature drops below 16 degrees, a drowning person may fall into a coma within 2 hours, and although there are some differences between individuals, death is likely to occur within 1 to 6 hours. Rescue is only possible if emergency services can arrive at the accident site within the 6-hour golden hour. Emergency vessels capable of offshore rescue in Korea include fishery inspection vessels and Coast Guard patrol boats. However, there are very few vessels in operation compared with the jurisdiction area. Although the sea in Korea is only 4 times the size of the total land, it is still difficult to secure the golden hour because there are only 200 ships or so that are conducting patrol and rescue. Therefore, we are planning and conducting tasks to optimize the deployment and operation plan of emergency ships using big data and artificial intelligence algorithms. First, it predicts risk of maritime accidents based on big data related to marine accidents and safety, and optimizes routes for emergency vessels by using artificial intelligence algorithms. Maritime accident risk provides information to passenger ship operation managers, maritime traffic controllers, ships' navigators, and users of fishing and water leisure, which are rapidly increasing in recent years. In the case of an emergency ship route optimization algorithm, it is provided to the Fishery Management Group and the Maritime Police of the central government that operate emergency ships to provide support to maximize the efficiency of prevention of marine accidents and initial response, and to provide customized services according to consumers. To this end, we collect all available data in the current maritime transportation field and promote data cooperation through interagency consultations. We perform pre-processing and data fusion by collecting marine weather data from the Korea Meteorological Administration, ship inspection data directly collected by the corporation, ship tracking data from the Coast Guard, and entry-exit data from the Ministry of Oceans and Fisheries. In particular, since the number of people on board the vessel contains personal information that requires de-identification, the protection of personal information is also an area that needs to be paid attention to recently. In the case of personal information protection, after pseudonymization, data is combined and utilized. If the accidental prediction model was classified only in spatial units in the first use case, in the second case, the accident prediction model is advanced by using both space and traffic density. The track data will be used as an exposure variable for accident prediction by classifying whether it is going to the fishing area or whether it is operating. After establishing a dataset for analysis by setting a pre-processing and spatial clustering system to anonymize personal information, the accident risk prediction model uses deep learning-based prediction models to select and utilize an algorithm with high prediction accuracy. Since all operating vessels currently have different operating capabilities, scheduling is necessary in order to connect each hazardous area to the port based on the actual operating status of the vessel. Vessels that can only operate a short distance only patrol the area they are in charge of. For ships that can operate farther, we have a plan to achieve the two goals of maritime safety and work efficiency by establishing a ship-specific sailing schedule that can patrol major hazardous areas while moving between multiple bases and providing information to the patrol agency. If the system is developed successfully, it will not only secure the golden hour crucial for search and rescue, it is expected to reduce the risk of accidents through safety campaigns promoted by the industrial complex and Coast Guard. In addition, it is possible to improve maritime safety by providing risk information to the rapidly increasing number of leisure and fishing boats, and increasing its utilization for evidence data to support various policies. This concludes my presentation. KOMSA is dedicated to ensure sea safety for everyone. Thank you.